In this video, I will be discussing about volumes of solid of revolution. So what is a solid of revolution? A solid of revolution is generated by revolving a plane area about a line called the axis of rotation. At this time, we will be using the second method of finding the volume of the solid of revolution, and this is the washer method. This method is very useful when the axis of rotation is not part of the boundary of the plane area being rotated. And the steps are here. Step number 1. Make a sketch showing the area involved and the representative strip perpendicular to the axis of rotation, as well as the generated washer. Step number 2. Write the volume of the washer generated as the difference between the two discs, the bigger disc minus the smaller disc. Step number 3. Assume that the number of washers to be indefinitely increased and apply the fundamental theorem of calculus. So to illustrate this method, consider a curve, say this curve that is defined by the function y equals f of x, and another function, say this is a function that is defined by y which is equal to the g of x. Now, these two curves are intersecting at these 2 points. Say this first point is having an x-coordinate of a, and this second point having the x-coordinate at b. And these two curves enclose a region that is this one. So if we rotate this plane area about the x-axis, you form a solid like this. So allow me to draw the curve. So this is the figure formed by rotating this plane area. So what you have is a three-dimensional figure that is generated by this plane area rotated about the x-axis. So it's a solid with a hollow at the middle. So this is now the figure formed by this revolution. So it's a solid figure here with a hollow at the middle. And our goal is to find the volume of this solid. So to find the volume, allow me to draw the same figure here. So this is now the solid that we want to find. Now remember that this solid is generated by this plane area here, but this plane area is approximated by these approximating rectangles here. And if you're going to rotate these rectangles here, you can form a solid that is almost the same solid figure with a hollow at the middle. Now remember that this solid form is not the same with the volume of the one that we are looking for. Why? Because there exists volume here for every rectangle rotated. And suppose we will consider one element in this one and take this out here, we notice that this is not simply a disc, but this is a washer here. There's a hole at the middle. So to find the volume of this is to find first the thickness of this washer, and the thickness is delta x. However, this washer is having a radius which is the y of this curve, and this inner one is the y of this curve, which is the g of x. So to find the volume of this washer, it's the volume of the bigger disc minus the volume of this smaller disc which is hollow at this time. So the volume is approximately equal to the sum of the volumes of all the washers, and the volume of the washer is obtained by the difference of the two discs. The volume of the bigger disc, which is this one, pi y squared delta x minus pi y sub 2 squared delta x here. And there are how many discs? There are n discs, but actually here there are 5 discs. Now take note that this y is the y of the upper curve, which is f of x. So instead of writing the y, we will write f of x. So f of x squared delta x minus pi of the y of this lower curve, because this is the radius of the smaller disc, which is the g of x quantity squared delta x. And there are how many discs? There are n discs, but we can factor out the common pi here. So pi is factored out outside the summation symbol, which is the summation of the square of f of x minus the square of the g of x. But we can factor here our common delta x for n washers here, of which the result is the volume of the washers. And you notice that this volume is not the exact volume that we want to find, because there are exists volume here for every rectangle rotated. However, this approximation becomes perfect when you will be slicing the volume to infinitely many washers. So this volume can be exactly found when you add all the volumes of all the washers, which is found by the square of f minus the square of g times delta x. And there are how many washers? There are infinitely many washers here. In other words, you will be slicing the volume to infinitely many washers. And we noticed that this is the limit of a Riemann sum, which we recognize that this is the integral of pi of the square of f minus the square of g dx, slicing it from a to b. So this is our formula when you want to find the volume which has a hollow at the center. So let's apply this formula in our example number 1. Find the volume of the solid generated by revolving about the x-axis, the area bounded by the curve y squared equals 4x, y equals 4, and x equals 0. So first, let us sketch the area bounded by these curves. And we know that this curve is a parabola opening to the right here. So this is a curve defined by y squared, which is equal to 4x. And we have the line that is horizontal but 4 units above the x-axis. And we have also the line x equals 0, which is the y-axis. So the area is this one here. And if we are going to rotate this area about the x-axis, you form a solid that is like this here. So this is now our solid here. But this solid, remember, is hollow at the center. So it has a parabolic hollow. And to find the volume of this solid is to slice this solid here. So let us sketch one slice So this is one of the slices if we slice the whole solid. So it's not a disc but a washer here. So what you will get is just a washer. Now remember that this washer has a thickness of dx because we are slicing vertically here, and the radius of this washer is 4 because this is at the line y equals 4, but the radius of the hollow, which is this one, is the y of this curve. So it's dependent to the y coordinate of this curve. So this is y. And to find the y is to solve for the y in this parabola. So y is equal to the square root of 4x. So this is the y in terms of x. However, we don't know the point of intersection between this parabola and this line, but we know already the y coordinate because this is y equals 4. So when y equals 4, here, this is 16. And 16 when divided by 4 is 4. So our x is 4 also. So we will write it here. When y is 4, then we have 4 squared, which is equal to 4x because our y is 4. So this is 16, which is equal to 4x. And dividing both sides by 4, we have x, which is equal to 4. So therefore, the point is having coordinates of 4, 4. Now that we have the dimensions of our washer, we can write the volume as the integral from 0 to 4 because we are slicing vertically. So we're slicing from 0 to 4, and at this point our x is 4. So this is the integral, the integration of all the washers from 0 to 4, whose volume is pi times the square of the bigger disk, which is 4. So 4 squared minus y squared, because y is the radius of the smaller disk, which is hollow here, and this is multiplied by its thickness, which is dx. So factoring pi outside the integral symbol, we have pi times the integral from 0 to 4 of 16 minus y squared, but our y squared in terms of x is 4x. And why do we change y in terms of x? Because our variable of integration is x. So integrating this binomial, we have the integral of 16, which is 16x, and the integral of 4x is 4x squared over 2, which is evaluated from 0 to 4. So simplifying our expression here, we have 16x minus 2x squared evaluated from 0 to 4. So substituting our limits of integration, we have 16 times 4 minus 2 times 4 squared, and this will be subtracted by 16 times 0 minus 2 times 0 squared. So our volume is equal to pi times 16 times 4, which is 64, and 4 squared, which is 16, times 2, which is 32. And this will be subtracted by 0 here, because we know that all of this goes to 0. So we have volume, which is equal to pi times 32, because 64 minus 32 is 32. So therefore, our volume is 32 pi cubic units. And this is our volume of the solid generated by revolving this area about the x-axis. Now take note that this solid of revolution cannot be solved by the disk method. Why? Because it has a halo at the inner part of the solid. And how do we know that we need to use the washer? Because the axis of revolution, which is this one, is not part of the area that is being rotated. Now let's proceed to our example number 2. Determine the volume of the solid generated by revolving about the y-axis, the area bounded by the parabola y squared, which is equal to 8x, and its latus rectum at x equals 2. So first, let us sketch the graph of the area bounded by these curves. And we know that the graph of this is a parabola opening to the right. And the latus rectum is at the line x equals 2. So this is the latus rectum here. But this one is defined by the function y squared, which is equal to 8x. So the area that is being enclosed by this parabola and its latus rectum is this one here. And if you're going to rotate this one about the y-axis, you will form a solid that is like this one here. So this one is the solid figure that is being generated when you revolve this area. So how do we find the volume of this solid? Now this solid of revolution cannot be solved using the disk method. Why? Because if you slice the whole solid and take one slice here, you see that this slice is not simply a disc, but it is a disc with a hollow at the center. So this one has a thickness of dy because you are slicing horizontally. Now at this time, our radius of this washer is 2 because this line is having an equation x equals 2, which is 2 units from the center. But the radius of the hollow, this circle, inner circle here, is dependent to the x coordinate of this curve. So this one is having a length of the x of this curve parabola, and this can be obtained when you divide both sides of the equation by 8. So this is y squared over 8, which is equal to x. So the volume is the sum of all the volumes of all the washers here, which is having the square of the bigger circle, which is 2, minus the square of the length of the inner circle, which is x. And it has a thickness of dy here. And slicing it from here up to here. But we don't know yet the y coordinate at this point, and also the y coordinate of this point. But that can be solved because we know that our x is 2. So when your x is 2, 2 times 8 is 16. And the square root of 16 is 4. But because this is a square root, it has 2 roots. The y, which is negative 4, and the y here, which is 4. So 2 roots when the x is 2. So the 2 points are 2, negative 4, and 2, 4. So this is an integration from negative 4 to 4 here. Now let us factor out the pi outside the integral symbol. So this is pi times the integral from negative 4 to 4 of 2 squared minus x squared dy. But we can simplify our volume by multiplying the whole thing by 2 because we just integrate from 0 to 4 of this 4 minus x squared dy. Since the volume above the x-axis is just the same volume below the x-axis, so we just integrate the slices from 0 to 4 and then multiply it by 2. So we have volume which is equal to 2 pi times the integral from 0 to 4 of 4 minus x, but we need to change this x because our variable of integration is y. So changing x in terms of y is to substitute this value of x, which is y squared over 8. So we square this one times dy. So volume is equal to 2 pi times the integral from 0 to 4 of 4 minus y to the 4th over 64 dy. And integrating that expression is 4y because the integral of 4 is 4y and the integral of y to the 4th is y to the power of 5 over 64 times 5 evaluated from 0 to 4. So substituting our limits of integration, we have 2 pi times 4 times 4. If you substitute this 4 here, and then this is 4 to the power of 5 over 320. And this will be subtracted by 4 times 0 minus 0 to the power of 5 over 320 here. So we have volume which is equal to 2 pi times 16 minus 4 to the power of 5, which is 1024, divided by 320. But this fraction can be reduced to its lowest term, which is equal to 16 over 5. When you divide 1024 by 64, the quotient is 16. And 320 when divided by 64 is 5. So we have 2 pi times the combination of these two terms, which is having an LCD of 5. So this becomes 80 minus 16 here. So volume is equal to 2 pi times 64 over 5 because 80 minus 16 is 64. Therefore, when 64 multiplied by 2 is 128 pi over 5 cubic units. And this is the volume of the solid generated by revolving this area about the y-axis. Now let's proceed to our last example here. Find the volume of the solid generated by revolving about the line y equals 6, the area cut off from the parabola y equals 4x minus x squared by the x-axis. So first, let us sketch the graph of this parabola. And we know that this parabola can be written as y, which is equal to the negative of x squared minus 4x. So completing the square, we have minus of the quantity x squared minus 4x plus 4 to make a perfect square trinomial. we are subtracting here 4 because of the negative outside. So to make a balance, we need also to subtract 4 at the left. So our y minus 4 is equal to the negative of this x minus 2 quantity squared. Hence, the vertex of this parabola is having coordinates of 2, 4 because of this one here. So sketching the vertex of this parabola, we have this one here. So this is a parabola whose vertex is at the point 2, 4. So it's a parabola opening downward. And the area cut off by the x-axis is this one here. But remember that this area is revolved about the line y equals 6. Now take note, it has coordinates of 2, 4. So our axis of rotation is this line here, y equals 6. So when you rotate this parabola, you form a solid like this here. And the solid is this one. So if you slice this one vertically, you will obtain washers all the time. Suppose we will take one of the slices here. So this is one of the slice. So if you take this out, you will have really a washer. It's a disc but with a hollow at the center. Now take note that the radius of this is 6 because this one is 6 units from the axis of rotation. But this one here, this smaller circle which is hollow at the center, is obtained by subtracting this 6 by this one here, because this one is the y of this curve. But remember that this curve is defined to be y, which is equal to 4x minus x squared. So to find this radius here, it's 6, this one, minus the y here. So 6 minus the y of this curve is the radius of the smaller circle. Hence, our volume is equal to the integral from 0 to 4, because you are slicing it from 0 to 4. And how do I know that this is 4? Because when your y is 0, our x is 4. How do I know it's 4? Because when your y is 0, we can solve for our x by factoring x here. So this is 4 minus x. So equating each factor to 0, we have 0 and 4. So when your x is 0 here, the y is 0. And also when your x is 4, the y also is 0. Hence, this is the integration of pi times the square of the bigger radius, which is 6. And then this will be subtracted by the length of the radius of the smaller circle here, which is 6 minus y quantity squared dx. And because our variable of integration is x, it is logical to change this y in terms of x, because our y is 4x minus x squared. So we have the integral from 0 to 4 of pi times 36 minus 6 minus this y, which is 4x minus x squared quantity squared dx. And if you factor out this pi outside the integral symbol, we have pi times the integral from 0 to 4 of 36 minus 6 minus 4x plus x squared. And when you square that trinomial, we have pi times the integral from 0 to 4 of 36 minus the square of this trinomial, which is 36 plus 16x squared plus x to the power of 4 minus 48x plus 12x squared minus 8x cubed dx here. And removing the inner parenthesis, we have pi times the integral from 0 to 4 of 36 minus 36 minus 16x squared minus x to the 4th plus 48x minus 12x squared plus 8x cubed dx. And we know that this 36 and the negative 36 cancels each other. So we have pi times the integral from 0 to 4 of negative 28x squared. Because when you add this negative 16x squared and negative 12x squared, we have negative 28x squared. And then this will be added to positive 48x plus 8x cubed, which is this one here, minus x to the 4th from this one, dx. So integrating this polynomial, we have this negative 28 times x cubed over 3, which is the integral of x squared, plus 48 times the integral of x, which is x squared over 2, plus the integral of this 8x cubed, which is 8x to the 4th over 4, minus the integral of x to the 4th, which is x to the power of 5 over 5 here. And this will be evaluated from 0 to 4. So evaluating this integral from the limits of our integration, we have negative 28 over 3 times 4 cubed. And this will be added to 24 because 48 divided by 2 is 24 times 4 squared plus 2 because 8 divided by 4 is 2. And this will be multiplied by 4 to the power of 4 minus 4 to the power of 5 over 5 here. And this will be subtracted by 0 because when you substitute the 0 to this polynomial, the result is just 0. So the volume is pi times the negative 28 over 3 times 64. And this is 24 times 16 plus 2 times 256 because 4 to the power of 4 is 256 minus 1024 over 5 because 4 to the power of 5 is 1024. So our volume is equal to pi times negative 1792 over 3 when you multiply this 28 and 64. And then this will be added to 384, which is the product of 24 and 16, plus 512, which is the product of 2 and 256, minus 1024 over 5 here. And combining all the terms by setting the common denominator of 15. So this becomes negative 8,960 plus 5,760 plus 7,680 minus 3,072 here. And if you combine all the numbers in the numerator, we have this 1,408 divided by 15. So therefore, our volume is equal to 1,408 pi over 15 cubic units. And this is the volume of the solid of revolution when this area is rotated about the line y equals 6. And that's it. If you learned something today, please check out my channel for more videos like this and click subscribe. Click the notification bell below so you'll get notified whenever I'll be posting a new video. Don't forget to like this video to show your support. And always remember to math your way up. Thank you.